A bond is a popular concept in lending in the Web2 world. We do not have many standards for Web3 applications. If you are interested in DeFi and want to learn more about the proposed standards for bond, continue watching. Welcome to PEEPanEIP episode 82. I'm Pooja Ranjan, and today we are going to have an overview of EIP-3475 abstract storage bonds with Liu. EIP-3475 is a standard track ERC proposal. It was documented in April 2021, and the proposal is currently in the last call, which is ending very soon. That is on July 30th. To learn more on the proposal, let's welcome you. Thank you for joining.
Thank you. So great to meet you all. I'm actually the author of the EIP proposal 3475, just like you introduced. What we call is abstract storage bond. So that's pretty much about the, let's say the proposal itself. And about me, I'm Liu again. I'm 29 years old. I was born in China and I lived 4 years in Canada, and now I'm in France. We founded a company with friends and also some team members in Paris. And we are trying to bring traditional bond and traditional financial product issued by those big institutions into DeFi. So that's basically what is our goal. And because we can't find any standard, and really good token standard to be used to issue bond, and we studied some token standards like 1400, 1462, and also our some let's say private implementation by Cedric and by other banks. But we found out the infrastructure itself is not that good. And because I was working for XApp, and back then I know that in the real financial world, the trading in bond and derivatives is a quite big market, and we should have the same size market, let's say, not too small than that, in DeFi. But we can't find it because, like I said, the infrastructure is not strong enough. So we try to bring the EIP-3475 and try to build that infrastructures, allow everyone, banks and individuals to issue financial products and with, let's say, higher and more available, more reliable logics and infrastructures. So that's basically the goal of the proposal.
Well, thank you so much. I know you have a great presentation to be shared with the community. So without further ado, let's peep in.
Yes. So I think I'm going to start. So the proposal itself called EIP-3475, and the name is Abstract Storage Bond. So the name, when we started to create the draft, it was a mutable coupled bond with the same number. So actually, we decided to change the name before the last call because I think that actually the abstract storage bond can cover as a little bit better the concept of the proposal. Of course, the proposal can be called. Of course, the proposal is a securitized bond. But I think most important part and differs with other proposal is our abstract storage, which I will speak a little bit later. And afterward, here is the standard in question. So we gave it a name, EIP-3475, and here is some explanation. So we said it's an interface for tokenized obligation with abstract on-chain metadata storage. So the idea about our standard, we are not trying to have a token like object. Actually, we created a tokenized obligation. So actually, the actual token itself, it's a smart contract. It's a contract saying that, let's say, with any conditions you can imagine. And if you trade your tokens to another person, which means that you are actually trading a contract to the, let's say, to the buyers. So basically, this is the idea of, let's say, a bond or financial derivatives. And the abstract on-chain metadata storage, it's, I think, based on my study, all the current token standards, they are using off-chain metadata. So in terms of financial product, it may not be the best idea because even though we can't modify the IPF string, actually we can just delete it and we will lose all the information, all the data related to the bond. So basically we put the metadata itself on chain, and to solve the questions like, because in Solidity, you have to specify the different types of variables, and in most of token standards, you have specified variables and you have specified functions to read them. So basically, in order to create a more reliable and more adaptable token standard, we need to redesign the structures of those variables and the storage itself. So that's basically the goal of the token standard. So here, what we have some, let's say, comparison with the existing token standard. Of course, we know there are other token standards, but I think those tools are most commonly used based on statistics OpenSecret. So here you have EIP-20, EIP-721, EIP-1155, and also EIP-3475. Here, the first line, they explain that the difference in terms of fungibilities. So EIP-20, fungible, so 721, not fungible, and both 1155 and our 3475 is what we call semi-fungible. So the definition is here, both fungible and non-fungible at the same time. So we check the 1155 documents, and this is the same description they use for their own token standard. And in terms of metadata, so the original EIP-20 is don't have the same metadata, and it has no variables or function to read it. But you, of course, you can use some extensions to get metadata structures inside of EIP-20. And for the 721 and the 1155, you have a native metadata functions already built inside. And normally you have your URI, and use this, you can find either IPF file or let's say a file on GitHub. So basically the data itself is off-chain. And most of the time, the metadata is only for, let's say, off-chain operations. So in some cases, it's fine. But in, let's say, if you are creating a financial product, it can be a huge risk. And here, in our 3475, what we call it's on-chain metadata. So basically, it's the same metadata, but metadata is built on-chain, and hopefully we found let's say gas-efficient solutions and to deal with this. And the third one is the token ID. So EIP-20 don't have a token ID, and both 721 and 1155 has let's say a single how can I say it? A single dimension of the IDs. So it's 0 to power 256 minus 1. So that is the total ID it can have. And even in the EIP-20, you can't find this token ID because, like I said, it's the same token ID. So what's the difference between us and the existing 155 and 721? It's actually we have used two dimensions, which is the X and Y. And in our token standard, we propose it as the class and nonce. So actually, I will explain why we need this. But the basic idea is that you need to fragment, let's say, a smart contract into very small pieces. And each class will share the same metadata. And under each class, you can have a lot of nonces. And those nonces has, let's say, a local nonce metadata, but they all have the same class metadata. So basically, that is the structure I'll explain later. And here you have some bunch transaction functions, and you have one in 1155, which is using two arrays. And in the implementation they proposed, actually they will check the length of the arrays, and the operations, let's say, has a lot of requires, and all those is not that cost efficient. So basically, we propose let's say a structure, a customizable structure, which we call transactions. So in the transaction structures, you can put all those information needed for one single transaction. And if you want to do multiple transactions, you just put, let's say, an array of the transaction structure. So in terms of efficiency, it's clear for, let's say, front-end manipulation, and it can save some gas as well. And here we have the most important part of storage. So I introduced earlier, the storage itself on 2071.155 and maybe all the token standards that specified. You have a symbol or variable to have to store a string, and this string can be read using functions that mentioned in the EIP. So that was basically the idea of the storage, specified storage, what we define. But the idea is that based on our study, so most of the banks and institutions, when they want to issue securities or some kind of financial product or some kind of derivatives, they are not using the same parameters. They're not using the same variables. So if you want to create a standard for everyone, you need to find a more adaptive method in order to, let's say, create the same interface and the same token standard for all. So basically what we do is we are using what we call abstract storage method. And here we say that our storage is more adaptable. And the final part is a type of supplies. So here you have all different kinds of supplies. And in 20 and 155, you have only one type of supply, which is total supply. And in EIP-3475, you have three types of supplies. Those are active supply, burn supply, and redeem supply. So I will explain why we need this later in the presentation. So here we explain who is going to use our token standard. And the first one, of course, is those big name banks. So here you have a news of the Société Générale and other banks who is already issued what they call the smart bond. So if you search for the smart bond on Wikipedia or on internet, you can find the smart bond actually it's not something new. But like I said before, the only thing bothers me and bothers most of the users is the end-to-end standard to standardize the whole process. And most importantly, if you are using ERC-20 tokens, so for all those metadata and all those variables and parameters you need to store for your bond issuing, you need to create a separated functions and separate variables, which is not efficient at all, and the code can be very messy. And of course, you don't have any front end can read those informations accordingly and efficiently. So here is the first potential users, traditional institutions themselves, big names. And the second one is, of course, the DeFi project. So in this presentation, we explain a little bit how our token standard can be used in AMM. So basically, we created a new model for the AMM, and this will reduce slippage, and this will reduce also gas fee consumption. So ideally, most of the DeFi projects can use our solutions and create what we call APM, automated parameters, which is far more efficient than existing solutions. And the final part is the standard can be used for applications, but actually the data structure itself, it's very easy to be adapted to other use cases. So basically, if you are using the standard for, let's say, DeFi game, something like that, you can use the token standard because the token standard can hold more information, and because it's using the ERC-3475 interface, all those merchandise can be traded on our secondary market. So basically, all the bonds and all the financial derivatives can be traded, and because the data itself is bounded with the class giving class ID and giving nonce IDs. So earlier, using a ERC-20 RP token, what you do is that you link some data, like say when you deposit your money and all that, with the address of the deposit. So what will happen if you want to trade your RP token? What will happen is that all the information will be lost. So basically, our solution is, let's say, bounded those important metadata, let's say values, with the token ID and nonce itself. So once the token is transferred from one address to another, all this information is transferred as well. So use this solution, we can create a secondary market for all those financial products that I've been talking. So here is actually the most important page in the presentation. And here you can find that this basically is this overall structures of the EIP-3475. you have on top what we say the smart contract level. So this is the whole thing basically is the same EIP-3475 smart contract. And here on the contract level, you have two things. The first one is the class metadata keys and the descriptions. And on this side, it's the given number of classes. So it's from 0 to the 256 minus 1. So basically, this is the class ID. Like I said, each class ID share the same metadata keys and descriptions, but they don't share the same values. So the values is put here, and this is, let's say, a mapping from the class ID to a string of values. And here, maybe you will ask, if you know Solidity, of course, you will ask how you can store different kind of different type of variables in a single arrays. So basically, we have a solution, what we call here, this solution. So I'll explain that later. The idea is that each class has different values. And for example, here in the structures, it has two values. It has value 0 and value 1. Value 0 here is the name of the class 0. That's what we call debit fixed rate 6 days. And the class 1 here is the debit fixed rate 30 days. So there's two different kind of type. Let's say a different kind of product under the same smart contract level. And on the second part is actually what differs class 0 and class 1. So here you have an integer. This integer, if you are using the value 1 here, and you can find the key of value 1. So it's the key one here in the metadata structures. You can find out this actually is the period of the bond. And this can be also the period, let's say, financial derivatives, when this contract will be taken place. So that's basically a time log. And here you have the key, and the key 1 is period, and the type is integer, and you have some description. So the whole metadata part is for the front end, and I'll explain how the front end is going to interpret it into readable natural languages. So again, under the class level, so under each class levels, you have the same nonce levels. So here, under the class 0, you have first nonce metadata keys and descriptions here, and you have also all different nonces. So from a given number from 0 to 2 power something. Here, the nonce metadata keys and description actually is the same structures like in the class, but the only difference is that each nonce, let's say, for example, the nonce 0 on the class 0 and the nonce 1 on the class 1, they all share the same metadata, same values, same metadata structure with all those nonces on the class 0. So even though the nonce 0 and nonce 1 is different, has different values, but they all share the same values and metadata here. And here you can see that we have some example. So here again, the key 0 is what we call maturity. So the idea is that if you want to issue a security, or if you want to issue some kind of financial product, let's say derivatives, you have a period, and let's say after the period or on the period, you bond all your derivatives can be redeemed or executed. So this number actually should be varies according to when you created the contract. So here you have two nonces, sorry, nonce 0 and nonce 1. So they are under the same class, so they are all both 6-day bonds. But here the maturity is different, because let's say the first day today you issue the nonce 0, and tomorrow you can issue nonce 1. And of course, this nonce structure can be used for other goal, but here it's only for some demonstration. We use it for the period, let's say the date of the different bond. And you can see here the balance of an account actually is how to say that the mapping is inside of each separated nonce. So the nonce itself, once it's transferred from your address to another, balance is changed, and all those metadata and all those values, like I mentioned, will be transferred as well. So that's basically the structures I spent a lot of time to introduce. So here on this page, you have on the left side, the part we standardized, and then write the part we didn't, let's say the implementation. So this is more, let's say, you have more freedom to define the structures here. But on this side, the interface, the ERC-3475, or say IERC, should always be the same structure. So this is the values we put it here. So again, back to here. So in this values arrays, what's stored is not actual variable. So you need to imagine that you created the box and you don't know what's inside of the box, but the box has 4 separated spaces. So the first space is a string space for string value, and the second space is integer space, and the third address for bool space. So you are manipulating the box, but you don't know what is inside. So in order to write the types of the data you want to write, and in order to read it, you need to find the types here in the metadata structures. So use the same thing, and so we tried several other methods to store those metadata. But this method actually is the most efficient and the most easy to use. I will explain maybe later, let's say other considerations. So here are some solutions. And on this page, actually, we explain also what is some kind of different implementation. So here you created a nonce structure first, and you put the nonce value and mapping it from each nonce ID to a string of different values. And they will have mapping of balance, same, active supply, burn supply, redeem supply. And this nonce structure is on the class structures. And the class structure has the values of the class, has the nonce metadata. So it's the metadata for the nonce under the class. And of course, you have the nonce IDs. So here is actual, I see the smart contract level. So here it defines that you have ID, and use this ID, you can get the class metadata. So the whole structures is defined with, let's say, those customizable structures. And here you have some demonstration of how to use this solution for the front end. So on the left side, you have the, let's say, the JSON strings achieved from the Web3. So actually, you can call one single function, actually it's 2 functions to get all those, let's say, informations. You don't need separated functions. You don't need to standardize those readable functions to get information you need. And let's say if you have 200 different variables and 200 functions to read them, and I think 200 is at least needed in the bond standard. So basically, you will have around 90% of them keep empty. And if you call those functions, you can't call them, it's there, but the value returns it's empty. So it's meaningless to have them. So basically here, one call, you get the JSON string here. And what the front end will do is first he will get the title of the values. So it's the key, let's say the key 0. So this whole keys is recognized by our front end. So basically the front end have, let's say, some kind of rules. You need to use this key for this key for that, this key for that. But the idea is that you can always keep one key ID empty. If you keep it empty, front end will not read, will read empty information, and it will not show in the JSON string. So the JSON string is the return of the usable data. Here, the title, you have a symbol, and the symbol is a string, and there's some descriptions, and based on the different class type, class IDs, you have different values. So here, sorry, it's here, let's say the name of the bond. So here for the demonstration, it's the same, but actually you can have all different symbols. So this is for the symbol, and it's because it's a string, it will be interpreted as a string, and because it's a symbol, it will be put, let's say, to the name sections on the front end. And same for the issuer. So the issuer is the, let's say, the minter in the ERC-20 terms. So who is the minter? Let's say you have some strings to describe them. And here you have D-bond. You can also have Société Générale and other bonds as the issuer. So basically, the issuer ideally will be a DAO contract, let's say, or a smart contract. But because of let's say some centralization problems, I've explained later, based on our discussion with some banks in Europe, Société Générale and others, they will may need another solutions. And here, the third one is the token address, and you can see it's address type and description as well, and you have different values. So all this information is get from Web3, and you use a script to translate them. And afterward, on front end, this will be the result. So basically, use the same front end. You can store 200 types of metadata, 200 types of values, and you need only one functions to get them. And you can also customizably select which parameters you want to show on your front end. So hopefully this will be, let's say, a good solutions for those financial derivatives and bonds, because the parameters is a lot. So maybe later I will show you some implementation we did with Société Générale, and you can see there are 20 parameters for each token IDs. So if you are using the old method, 20 functions, 20 variables, and here it's much simpler. And on this page, we explain our solutions for batch transactions. So actually, basically, it's the same, but we have structures and you have class ID, nonce ID amounts, and you will package those transactions into arrays, and you do them, let's say, multiple times. So the only thing we do is we don't have the requires of tracking the length of each arrays. So basically, it's in terms of gas fee, it's a little bit more effective. And here, now different types of supplies. You have redeemed supply, active supply, and burn supply. So why we need three types of supply? It's because if we are talking about obligations, so actually one obligation has three statutes. So the first one is when the obligation is not executed, the terms is not met yet, and the contract are there, and they can be executed later. So this is what we call active supply, which means that it can be executed or it can be burned. So the redeemed supply is the supply that been destroyed after the contract is executed. So the idea is that if the redeemed supply is added, means that those supplies, let's say the smart contract, are being executed and all the terms are met and all the actions are taken. So this is a redeemed supply, and you have the burn supply. So the same thing, when tokenized obligation is inactive supply status, it can be burned, and you just destroy the contract without, let's say, execute the actions inside the contract. So you abandon your right to something. So you can destroy the obligation, and those supplies will be put into the burn supply. And of course, the total supply is the sum of all three types of supplies. And you have some events. So basically, it's actually the same thing as ES20, but using our solutions, our front end can capture all those event issuing. So the idea is that once you get some EIP-3475 in your wallet, in your address, our front end can read it and will get that smart contract address and the class and the nonce IDs accordingly. So basically, you don't need to add any smart contract. You don't need to do anything with your hot wallet. Our front end can read them accordingly. So this here, you have some batch transactions, and you can see they are all using the same structures, what we call the transaction structure. Here. And there are also some safety considerations about approval for function. So basically, we have two functions. One is approval for, and I think the other one is approval. So basically, two functions is different. One, you give the total access of your bond apart from ownership to some address, and this address have all those access of your let's say of all those bonds under your address. And here you have also ways to give, let's say, a transaction. So basically, you are giving address a one-time possibilities to transfer or to manipulate the bond. So basically, the two functions are different, and that is very important in our standard. And I'll explain why you need this operator rows, which is not that decentralized, but it's necessarily needed. Here you have some examples. So it's basically our default implementation. You can get from our GitHub. So if you are interested in the implementation itself, you can take a look. Here I just go through this. So here we created a class, and we created a class of bond. So here you define the keys. So you define the keys ID 5 as period, keys ID file types is integer, and the description is details about issuance and redemption time. And here you have also the values. So the class 0 of the values P5, or let's say the key 5. And this is a type of integer, and this is 180 days. So basically use this, you can actually store all those, let's say, variables, and in the same way, like you store those variables, you're creating a new variables. So yeah, basically the solution. And here you have nonce metadata, and here in the implementation, you have maturities. So all the different nonces have different maturities, and the integer again, and description. So here you created 3 nonces, not 0, 1, and 2. So they are the same class, but because they are using the same maturity values, so this bond can be redeemed, let's say 6 months later. This is 6 months plus 1 day, and this is, sorry, this is 6 months plus 2 days. Yes, and here is our let's say solutions for existing DeFi protocols. So basically, this is a more developed version of the AIMM. So the traditional AIMM we know is that you have a pair and you are using very simple functions x multiplied by y and equals constant k. So basically, it means that in the same smart contract, you can have only 2 tokens. And let's say if in terms of Ethereum, you have maybe 200 pairs, maybe more than that. So what happens is that in each pair, the amount of Ethereum will be far less than the total amount. And what happens is if you want to swap, and if the difference x, let's say the dx, the difference in Ethereum is very big compared with the x, what will happen is that there will be a very important slippage, and the money will be lost in this way. And what on the market, there are a lot of arbitrage. They find those kind of opportunities, and they try to move the liquidity from other pools to this pool, let's say with a variation of the price. So basically, the APM is a tool that actually it tries to imitate, let's say, simulate the same process, but this time the arbitrage reward is not given to the arbitrators. It's given to the people, to the person who swapped. So basically, the slippage will be reduced significantly with this method. So basically, what is used here is instead of using 1 pair, we put all the tokens inside the smart contract, what we call a multi-layer pool. So here, if you click this, you can find our implementation. And with the same pools, you have all the tokens. And we will issue a LP token, use EIP-3475. And what we will get is on the LP token itself, it defines when you deposit, what interest you expected, the type of your bond, and of course, the type of the token you deposit and the amount. So basically, again, like I said, this actually is the LP token, but it builds all the information, all the variables, parameters on the class and nonce IDs. So basically, it's far more easier to change them without losing any information. The same for all other types. And what we do when someone wants to swap is that they, let's say here, you have the multi-layer pool, and the multi-layer pool actually is a combination of what we call a virtual pair. So each virtual pair is like a pair contract, but it's in the smart contract level. So inside of one multi-layer pool, you have a lot of different kind of virtual pair, and the virtual pair use AMI. The AMM. So what will happen in a very simple example here, you want to swap your Ethereum against USDT. So earlier case, the Ethereum is spread in separated pools. And what you can do is that you send Ethereum to this pool and you add the different of Ethereum different DX. And you need to remove some USDT, which is minus DY. So what will happen if, like I said, the amount of the difference in X, if this amount is huge, the slippage will be, let's say, ridiculous. So what will happen in our solution is that all of those pools, actually, they can communicate with each other. So with the previous solutions, separated pair contract, you can't connect to other pools. So basically in our solutions, because they are in the same smart contract and they are using the same LP token, it's the same contract who will issue all those LP tokens. So what will happen is simply they can communicate with each other. And in the example here, what will happen is that you put in Ethereum to exchange of USDT. But what will actually happen is that the Ethereum itself is not putting into the Ethereum USDT pools. Actually, we have what we call a big L. So the big L is the sum of the total Ethereum in all the virtual pool pairs. So what will happen is that this is like someone doing an arbitrage after a big slippage and try to remove the tokens from one pool to all other pools and get the reward. So this actually is simulating the same process, but only changing the big L, what we call the sum of X. So it's a big X, you can also say a big X, and when you swap, you change the big X instead of each separated X, because we know that the pool is connected and we know the USDT, USDC, and all other tokens that has almost the same value. So we can use this method to reduce significantly the slippage. And here is some explanation about EIP-3475 comparing to Ethereum. You have first, most importantly, on-chain metadata storage. And you have decentralized bond and derivatives, which is not available at all. And all those can be, let's say, created using our standard. And of course, we'll provide a secondary market for those financial products. Here you have a better use case of AMM, which is this implementation they introduced. And here you have the reduce of gas fees, and in some actions, not all the actions, but in some action, and of course, significant reduce of the slippage in swapping. And the last part is the abstract and adaptable storage. We can use this for all the needs. I will not say it's almighty. You can do anything with that, but it's very adaptable. Why standardized? So actually, this basically everyone needs to answer, right? So what kind of token standard can offer? So basically all those things, and even all those things, so they aren't any solutions. So if you are using the multi-layer, so the multi-layer is not something very difficult to come up with. But the difficult part is how you are going to manage the LP token. So with 155, with all the existing standards, it's impossible because the metadata, the values is not stored in based on IDs. So basically, what you need is EIP-3475. Otherwise, the multi-layer pool solution will be impossible. That's what can bring to the community. And of course, once standardize it, because you need to have a standardized interface, and you need to have the standardized ways to use this, let's say, more functional infrastructures. Otherwise, it's not infrastructure. It's just some random solution proposed by us, used only by us. So it's meaningless. So why it's standardized? Again, for the front-end purposes and applications. So basically, we provided a hot wallet. Like I said again, use this wallet. You don't need to enter any information. We just capture all the events and we can know that in which pool of which protocols, which type you deposit what, on which date, and when you can redeem, and what will be the result to redeem right now. So basically, all those informations can be stored, shown, let's say, in the same place on our front end, which is not possible before. When you have very let's say very costly manipulations. Let's say you need to add all those address in order to get these functionalities. So maybe if we have time, we will show the front end later. And here you have other consideration. What we discussed, we tried the TLV method, which is less efficient than our full entity box method. And for the metadata front end, we thought we could, let's say, force it into the EIP, but we've abandoned this idea. And you have some class and non-structures we consider, but not used. And here we have some very quick comparisons with the existing solutions. So right side is our solutions. For swap, it's same price or a little bit more expensive. But for all other manipulations, especially creating pairs, because we are just add some values into the mapping. So it's very efficient and almost consume no gas. And you have other liquidity, which is very cheap compared with Uniswap solutions or Curve solutions. So basically, that's this pretty much it is about the presentation.
Well, thank you. Thank you so much for this presentation. I loved it, especially the table that you have shared about EIP 2071 and 1155. And I hope the detailed explanation of metadata, front-end, and batch transaction will be helpful for DeFi dApp developers. It's quite thorough presentation. So yeah.
Thank you.
Thank you. Thank you for that. I see a number of people join in the call today. Some of you may have been muted. If you have any question, please drop in the chat so I can unmute you. And welcome, Cedric.
Hi, all. Thank you.
Thanks for joining. While people are trying to add questions here, I have a few questions collected already, so I can maybe share that. My first question was why a standard? I find it good from a project's perspective, right? And my understanding is dbond, the project, is more or less doing what you are suggesting here.
Actually, what we call a token standard is not for dbond. Actually, we discussed with several European banks. So like I said, Société Générale and the European Investment Bank. So basically, they see our solutions, and of course, we see their solutions as well. So basically, the smart bond itself is not a small market. There are major players that already participate inside. The only thing they need is a standardized way that can be, let's say just you need a standard in order to build the real markets. Otherwise, you're just playing. Sorry for my video. I think it's cut off. So what I try to say is that there are other players as well. So all those banks were cited, and we have several discussions with them already. And they all think they need the token standard in this way. So I do say that this token standard is not only for us, but of course, before this can be a standard, nobody going to spend time and energy to make this a workable product. So that's why we need to develop our own product first and to show that the efficiency of these solutions. And of course, after this, the Société Générale and other banks, they will join, and all other DeFi protocols we've been discussing with, they will see the potential in these solutions and they will join. So basically, for myself, I will have no doubt concerning the efficiencies and superiorities about about this standard in bond manipulations. But the idea is that you need to tell the market, and most importantly, you tell those developers that they need to redo all those solutions they had. So you need to have a very strong showcase, and this showcase for now, it's only our product and also Société Générale and European Investment Bank, because we, before the standard becomes a standard, it's harder to find a good, like say, a good users for the standard.
Wonderful. I mean, like this is always encouraged to have some implementation before we move any proposal to a standard. And if the original team is involved in building a project and then bringing it, the implementation of that proposal is really a good example to have.
Yeah. Also, we have other example, for example, for association had Fox, SG Fox. So basically, I think I will add a new repo and we can showcase other solutions we propose to other major players. So if you will be interested, you can see other implementations we did for other organizations, and they will be on our GitHub. So if you follow our GitHub updates, you can find them, let's say, in 1 or 2 weeks.
Maybe you can share the link to the GitHub with me and I will add it to the description.
Yes, we will do that.
All right. Well, thank you. My next question is about gas efficiency. In the motivation section, it is mentioned that the function define is this EIP provides a gas efficient solution. And you mentioned about like multi-layer pool, right? So maybe if you can explain or elaborate how it provides a gas efficient solution.
So basically, in terms of multi-layer pool, so let's say from the most obvious one, creating pair. So using the old solutions, let's say if you are using in-sub solutions, what you need to create, if you want to create a pair, you need to create a smart contract with a new RP token contract, and you need to call the factories to deploy the contract. So that's why it will generate this amount of gas fees. And because in our method, the contract is already developed, it's already deployed, sorry. So what you need to do is you just need to create a virtual pair, and you need just to call functions to write the information about those two tokens in the pairs into the mapping. So basically, compared with the publish a new smart contract, it's far more efficient. And other way, if you are trying to swap Ethereum against some, sorry, not Ethereum, if you are trying to swap a rare token against another rare token, so very likely you can't find pairs. So what Uniswap is doing, because the pool can communicate with each other, so actually they are just looping the swap itself. So you will pay out, let's say, around 2 times the gas fee in order to do the transaction. But if the pool is connected one to each other, so basically you can manipulate the whole pool and the virtual pool inside, just let's say in single transaction, which of course will be more efficient in terms of gas fee consumption. But to be honest, when you are swapping, let's say in a single pair, our solution is a little bit expensive than the existing ones because you need to get the virtual pool from mapping, and this will cost some gas fee, but the difference is not huge. So that's why overall, I think our solutions will be more efficient. But the most important part of our solutions is not even the gas fee itself, it's about the slippage. So slippage is a huge problem in AMM. So basically our solutions, we believe, can give a lot of possibilities to reduce significantly the slippage itself.
Interesting. So yeah, this looks like a good example, and it provides a considerable thoughts for people like the dApp developer to be maybe adopt this proposal.
For me, it's fine. I think I said everything I need to say, and I'm not sure if for the audience this easier to understand what we try to do. Actually, what we want to do is very simple. It's just to build something, let's say, adaptable, and build the same front end for everyone, for everything. So this can bring a lot of possibilities, because EIP-20 and 71, all those token standards, because again the storage is specified, it's very limited. So we are not seeing a lot of innovations in DeFi. And to be honest, for the past 2 years, I didn't see any exciting project because the same token standard issue. So basically, I hope that our token standard will bring more possibilities into Ethereum ecosystem. And of course, if that will be the case, the implementation of EIP-3475 will be a possible solution.
I hope so too. Thank you for sharing all these information. I have noticed a few minor editable points. If you can maybe update the proposal, I know it is already in the last call. I can also add those as comment over there, but just for sharing, for documentation purposes, we generally prefer that an EIP, even if it is of ERC category, may be represented as EIP. For example, in backwards compatibility, it is mentioned that this standard interface is also compatible with ERC20. And if you look into the link takes to EIP20. So that is just a small update I'm requesting.
Okay. Just to give me some sec, I'll note this.
Yeah, I mean, I can send you a list. I have just 2-3 minor points.
Great.
I will send it to you. That's all right. I wanted to say this is like very well documented. I also looked into the assets library of it, and you have added the assets for different metadata. Those are all wonderful. Thank you so much for putting so much of effort into one proposal to make it as a standard. Right, it's time to wrap up. Do you have any final thoughts to be shared with the community?
So very thankful for your time, and also for the other audience. Thank you for coming. And if you have further information, further questions, or if you need further information, you can send me a mail. So you know my contacts. So I will be expecting them.
I just wanted to add thanks for the audience, and we are very excited, to have the bounce back of the community of this, because it's a very exciting project. And yes, like you said, like Yunan said, I'm very sure that it can be something huge, because it's a very let's say a very improvement. So for everything. So thanks for Ranjan, thanks for everyone, and yes, thank you.
Well, we appreciate you all taking out time and talk about EIP-3475. I hope it will be adopted by DeFi projects after becoming a standard. Thanks to the entire team of DBond. On this note, thanks to all YouTube viewers for watching this episode. Check out description for related links. Hit like and share if you like the talk. Should you have any question on this proposal or any other, please let us know at ETH Subscribe to the channel if you haven't done it already. See you next time with another interesting proposal. Till then, keep sharing your love with Ethereum cat herders. Have a good one, everyone.